I'm Rihanna Clark, and today we're going to be looking at some examples of problems in the forms of simplifying a single radical expression, multiplying two or more radical expressions, adding or subtracting two or more radical expressions, changing a radical expression to one using fractional exponents, and solving an equation that involves exponential expressions. Alright, so the first one, simplifying a single radical expression. So our problem is the cubed root of 48x to the cubed. So the first thing we have to do is do a factor tree of 48. Okay, so this is the prime factorization of 48. So that'll go under the radical, and you still have the index. So that's 2 to the 4th times 3 times x cubed. Okay, so from 2 to the 4th, since it's the cubed root of it, then you can pull out 3 2's from it, because all you're saying when you write it to the 4th is it's 2 times 2 times 2 times 2. So you can pull out 3 2's from it. 2 cubed times 2 to the 1st times 3 times x cubed. And since it's 3 for the index, you can pull out anything that has 3 for the exponent. So you're going to pull out 2 cubed, and the cubed root of 2 cubed is 2, and the cubed root of x cubed is x. So outside the radical you're going to have 2x, and then inside the radical you have left 2 times 3. You can simplify that to 2x times the cubed root of 6. Now, when you're doing this, don't make the mistake of dividing by 3 just because the index is 3. It's asking you the cubed root. So it's saying 2 times 2 times 2 times 2 times 3 will equal 48. Alright, next one. Multiplying two or more radical expressions. So we have the 6th root of 5 times the 6th root of 3. So, since we're multiplying, it doesn't matter if we have the same base or not. So we can just go ahead and multiply them. And we keep it under the radical, and we keep the same index. Make sure you don't multiply the index too, because you're just multiplying the bases. And your final answer will be the 6th root of 15. Number 3. Adding or subtracting two or more radical expressions. Alright, so the first thing we have to do is, since we're subtracting or adding, in this case we're subtracting, then we have to look at the bases and see if they're all the same, because if they're not, then we have to do the prime factorization since we're not multiplying. Okay, so we look at them and it's 81, 72, and 24. So we have to make the prime factorization of all of them. So we'll start with 81. So there's our prime factorization. It's 3 to the 4th. So since it's the cubed root of it and we have 4 of them, then we can pull out 3 of them. So it'll be 4 times 3 times the cubed root of 3, and that can simplify to 12 times the cubed root of 3. So now we do 72. Okay, so here's the prime factorization of 72. So it's going to be 2 cubed times 3 squared. So the only thing we're looking for to pull out is cubed, so we can pull out that. And so the cubed root of 2 cubed will be 2. So 3 times 2 times the cubed root of 3 squared. So if you simplify that, 3 times 2 is 6. Cubed root and 3 squared is 9. 24. Okay. Alright, so remember the only thing we're looking for is under the radical is stuff that's to the cubed. So we see there's 2. So 3 times 2 times the square root of 3, and then 3 still under the radical. So it's 6 times the cubed root of 3. And now we bring down all the signs. Alright, so now we can begin to add or subtract them. So we're still subtracting, so we have to still look at the bases. Okay, so we see that these two have the same base, so we can go ahead and subtract those. So we just do subtract 6 from 12, which will be 6, and we leave everything else. Make sure you don't subtract the index or subtract the base, just leave it. And then go ahead and bring this down with that sign. And there's your final answer. Okay, number 4. Changing a radical expression to one using fractional exponents. So, our problem is x to the 8th fifth. So we want to get it in the form so it's just x. So what we have to do is the inverse operation. So it's an exponent, so you might wonder how you would do the inverse of that. It's simple. You would just do the reverse of 8 fifths, which is 5/8, and you raise that quantity to that. Okay? So that cancels out, and you're left with x. Make sure that when you do the reciprocal of 8 fifths, which is 5/8, that you don't put it in the form of just multiplying it. Make sure it has to be the exponent. Okay. Last one. Solving an equation that involves exponential expressions. So, 3 to the 2/5 quantity to the 5th. Alright, so the first thing we want to do, it's a power raised to the power, so we would multiply it. Okay, but you have to remember that's really 5/1. Make sure you don't do 5/5, because it wouldn't be the same thing. Okay, so 2 times 5 is 10. 5 times 1 is 5. That simplifies to 2, and that's still the exponent, so it's 3 squared, which simplifies to 9.